So for equilibrium problems, especially addition and removal, the main thing you look at is the states of matter, because the states of matter determine whether or not it will change the equilibrium. Meaning that gaseous and aqueous states are the only ones that affect equilibrium. So solids don't actually affect equilibrium, only gaseous and aqueous do. So let's start the problems. So instead of memorizing what can happen, where you can easily get messed up, I like to think about it as stick figures. So you have your stick figures, you have reactants and products and an equilibrium wall. So they're pushing with the same force on the wall, so it's not going to move. So the addition of O2. So what is O2? O2 is a reactant because it's on the left side. So O2 is a reactant. So what do you do with O2? Well, since we're adding it, we can add it to the right side, or I'm sorry, left side, because it's a reactant. So we add O2 to the left side. So now since we added O2, what happens? Since we added O2, there's two people on one side and one person on the other. So obviously if one side is stronger, it's going to shift in that direction. So since the two people are stronger, it's going to shift right. Okay, so next, it's the removal of H2S. So the removal of H2S, we're back at 1 and 1. We're back at one person and one person on each side, so it's equal. The equilibrium wall is not moving anywhere. So we're going to remove H2S, which is a reactant. So if we remove this H2S, what happens? Suddenly, this guy's still pushing, but now there's nothing pushing back. So what's going to happen to the wall? If he's pushing left, right? If he's pushing left, the wall's going to move left. So it shifts left. Okay, so the next one, removal of H2O. What is H2O? H2O is a product because it's on the right side. So what happens? We're removing H2O. So for this stick figure, we remove him because we're removing a product. So what happens? So now we have one guy on the reactant side pushing on the equilibrium wall, nothing pushing back, so it's going to shift to the right. It's going to shift right because there's nothing pushing back. He's going to push as he's always done, and now since there's nothing resisting, he's just going to shift to the right. So it's shift to the right. And finally, the addition of the solid. So when you add something solid, it doesn't affect the equilibrium because solids and liquids don't affect equilibrium. So it will actually be no effect. No effect will be found if you add the solid because only gaseous and aqueous states affect the equilibrium when you add it or remove it. So I hope that helped, and thanks for watching.